Hello, my name is Larry Tannenbaum, and I am pleased to have this opportunity to present this short presentation on natural language processing and understanding and the role in the imaging enterprise. We won't have much time to really set the stage here in this 10-minute presentation, but I'll touch it for a moment on where AI fits in the society and the imaging enterprise, but we're really going to focus on the natural language piece of this particular presentation. We know what AI is. It's essentially a branch of computer science that lets computers do things that are associated with human intelligence. AI has been described as the new electricity. It's all around us, and things like online advertising. It's what's behind autonomous driving. And there are many areas where computers are already outperforming humans. We know at this point that computers are better than humans are at image recognition, and they've gotten to the point where they're actually better than humans at speech recognition. Now, there are a lot of different areas where AI impacts with the world. The one we're going to focus on today really is the natural language processing and understanding part of this particular presentation. So what is natural language processing and understanding? These are techniques that aid in the conversion of text, unstructured text, into a structured representation. It essentially enables computers to derive meaning from our natural language input. Used on medical records and reports, these tools can enable automatic identification and extraction of information. And with that in mind, you can see there's a lot of different areas where this tool, NLP, can impact on the imaging enterprise, impacting on decision support criteria, utilization management by reading records, assisting in scheduling an appointment booking, things like reading the record and knowing what the previous report said, and will actually design and tailor the acquisition to what we need to do that particular day. It can actually look at what you've said in your report, even look at the images when combined with computer vision, and assist in making a diagnosis. And something we're going to focus on a lot today is using NLP and NLU to impact on the actual reporting process, reporting content, and report follow-up. So really, that's what we're going to talk about in this next few minutes. So when you think about enterprise opportunities, you look at the typical healthcare cycle. Patient comes in, sees his doctor, takes a history and physical. Okay, then makes an imaging request that goes to the wrist. The radiographer sees that request in the wrist and does the exam, picks a protocol, picks a modality, does the exam, does the acquisition, goes to the PACS, comes back to the radiologist as a recommendation and an interpretation, which then goes to the doctor that makes a clinical decision. Great, very smooth, very easy. Are there any opportunities for error here? Well, yeah, there's quite a few. We can do a poor job at utilization management because we haven't really looked at the record and considered that in terms of processing the imaging request. The radiographer may choose the right protocol, may choose the wrong protocol because he doesn't have access to all the records, and we can use tools to help with that. When we do the actual imaging acquisition, is the image quality where we need it to be? Are the images what we needed to obtain to answer the clinical question? And even after the radiologist has seen it, we can use a combination of natural language processing of reports and computer vision to identify errors that need to go in the report. We can even look at errors between what the report says and the way the coders interpret what's in the report, and actually look at the performance of the entire process in terms of peer review. And we'll talk about all of that. But all of these are opportunities for natural language processing and understanding in the healthcare enterprise. So essentially, natural language understanding is capable of extracting information embedded within free text radiology reports, things like the history, which can help inform the radiologist of what needs to be done, looking at imaging findings in the prior and current reports so that you can make sure that the radiologist doesn't fail to comment on the pertinent positives and negatives based on what's gone on before, and even impact on the way follow-up recommendations are made and followed up on. And again, this can easily contribute to informed utilization management, which some people call clinical decision support, by looking at all of these records. Now, again, when it comes to the actual imaging process, you can actually use what's in the record to determine what actual protocol needs to be done in any given case. This, of course, reduces the need for human engagement, someone going through all the requests, because this will increase efficiency. It makes sure that the exam is more pertinent to the questions at hand, increasing its value. When you do things right the first time through, you have fewer callbacks. And of course, that makes a big difference. And it all leads to better patient satisfaction. This is an ultimate patient-centered move, as well as referring satisfaction, because not only did you do the right exam, you commented on the key clinical question and delivered that to the doctor, and again, leading to a much higher level of satisfaction. Now, again, these tools, which can essentially read radiology reports, can be really very helpful, because they can lead the radiologist to what the important actionable findings were in prior reports to make sure they're addressed in the current reports. And as I mentioned, this improves the pertinence of the report in the current episode of care. And again, it can actually take all of the unstructured report information that we put in all reports on a routine basis and actually pull out content, structure it, and this can be used for data mining, follow-up, and research. Now, when you combine natural language processing and understanding with computer vision, the typical AI image interpretation, you can then do things like compare the active report, the report itself, with what the computer sees, and avoid critical omissions in this process, making sure that they drive properly. And of course, this leads to overall quality. And frankly, when most radiologists hear about this, their light bulbs go off, their warning lights go off. Because one of the admonitions we have as AI impact on the imaging enterprise is it can't make more work for the doctor, the way traditional breast CAD did in the old days. It's got to make things smoother. So frankly, if this tool was actively reading the images and reading the reports and just flagged everything that it saw, it could cause a problem. But when these things are done in a clever way, it can actually limit the flagging, the alerts, to only areas of discordance where there is something in the image that isn't in the report. So the radiologist can only focus on where the mismatches are, and this can minimize alert fatigue. A typical example, the intelligence might see the liver image lesion, and if it's not in the report, as in this example, it can say, hey, you know what, there's a liver lesion you didn't mention in your report. This is a paper I published with the folks from iMedis, where they actually looked at their lung algorithm. And this particular algorithm combines computer diagnosis, computer vision, looking for lung nodules, as well as natural language processing and understanding, reading the report, and only flagged in this particular experiment when there was a discrepancy. In other words, if there was no follow-up called for because the nodules a nodule wasn't identified, this would only flag if nodules were identified that wouldn't be followed up based on what the report said. So it's really kind of clever way of going about this, and that's from the folks at iMedis. Now, again, we have other challenges in the healthcare enterprise, and one is coding. We employ a lot of people in the coding process to make sure our reports don't get, our billing requests don't get knocked back. And if you can use a computer, which was really designed for this process, to read the report and choose the appropriate coding, you can massively reduce your staffing costs and improve concordance, accuracy, and first-time payment. Again, the same combination of tools, computer vision and NLP, can actually be used to get a more clever version of peer review and learning. And the nice thing about that is that these don't require FDA approval. You can just use this as the quality improvement measure and to make sure that things aren't being missed. Another great opportunity here is to make sure that there is follow-up, that patients return for imaging after their follow-up recommendations are put in the report. There are challenges here with these things. Radiologists tend to report them in a variable way. There is inconsistency within and between practices, and this irritates everyone in the process. If indeed you had a tool that could read the report and know the guidelines, it can actually improve the consistency and appropriateness of this practice and generally lead to happier doctors. Another thing these tools can do is can identify the fact that you asked for a follow-up in the report. That's an interesting thing, because the folks at Agamon have shown that 55% of the recommendations that they look at in this large survey of 3 million reports weren't followed up on. The patients didn't come back. You can use these tools, things like Agamon that I mentioned, as well as things like White Rabbit, which actually had a very positive impact on patients returning at RadNet. They've actually produced a 25 to 50% increase in patients coming back for follow-up using these types of tools. Now, the other thing where NLP can impact on is on things like imaging reports. As you know, the 21st Century Cures Act really added some new burdens on the radiology process to make sure the reports are accessible and then readable by patients. And this is the ideal tool that can actually take a report, allow the patient to see it, even tailor a report for different types of clinicians, increasing the impact on decision-making, improving patient satisfaction, and of course, making your facility more attractive to individual institutions. And again, one of the obligations we have now is to make the reports readable for patients. It's actually relatively easy for these types of tools to add a lay summary at the end of the reports. All right, so I'm a little over time. I think I'll stop right here and say, I hope that was a reasonable survey for where these tools can be used in the imaging enterprise. I'd like to thank the organizers for having me and thank the folks that have registered for this meeting for their attention. Thank you and good day.